Hey guys, welcome. This is our 2.5 video. Label it Reasoning in Algebra and Geometry. And what we're going to do today is we're going to connect algebra stuff with geometry stuff. Okay, let's go ahead and get started and write down some stuff. Alright, first thing, write this box down. Okay, so you're pretty familiar with most of these. And what we're doing is we're getting into our first steps of what we call a proof. A proof is essentially me saying, here's the question. Here's the answer. I'm actually giving you the answer, and then you explain how I got there. Okay, so a proof's kind of weird. You're not solving, you're explaining how we get to somewhere. Okay, so it's like knowing where you are and knowing where you're going, but then you're explaining how to get there. Okay, so it's like doing the Google Maps of how to get from point A to point B, because you know both points. How do you get there? So here's some ways that we can actually use to reason how we get there. So if I add something to both sides, that's called addition property. If I subtract from both sides, subtraction, multiply, multiplication property, division, division property. Reflexive property just says A is equal to A. It's like a reflecting, like looking in a mirror. Okay. Symmetric property is different. It's saying, like, for example, Tom is equal to Tim, and Tim is equal to Tom. It's almost kind of like a converse, if you will. And transitive property is very similar to our law of syllogism, which A equals B, B equals C, thus A should equal C. So it's kind of taking two things that are not related and using B as that middle person. And then substitution property we see a lot, and that's like when you plug in 5 for x, that would be a substitution property. Okay, so there's some vocab there. Let's get some more. Okay, well, we also have the distributive property here, and that's pretty straightforward, so write this down, but it's basically saying we can distribute something in. A times B plus C is AB plus AC, and we got one more thing. Okay, and the last piece right here is this, and this is what we are all about. This whole idea of reasoning and logic and all that is to get to the point of doing a proof. Okay, so a proof, so you're going to write this down. A proof is a convincing argument that uses deductive reasoning. A convincing argument. And deductive reasoning is reasoning using facts and statements, not observations. That's inductive. So a proof logically shows why a conjecture is true. Okay? So I say this, here's the right answer. The proof is going to show why it's true. And the most common proof we're going to see is a two-column proof. At least it lists each statement and then reason. So here you see a statement and then the reason. Okay? So the first statement is usually given. Okay, so we say given, it was given to me. And then each of the following statements should follow logically from the next one or the last one. You don't want to skip around. And then you want a reason for each that you're doing. And your last statement is always going to be the proof, which is right here. And notice it's the last statement, as I just crossed that out basically. And that's what it's generally going to look like. Okay, so let's get into some examples. Okay, so here's our first example. We're not going to do a ton of examples today because we're going to get a lot of practice in class. But here's our first example. It says, what is the value of x? So go ahead and draw this picture, justify each step. Now, let's just chat real quick about how we would solve this problem. Okay, well, I see that this is a linear pair. They're supplementary, so that we know these two are going to add up to 180. Okay, so we have to justify everything that we're doing. So let's go ahead, and I'm going to actually use this thing to help us out today. So I'm going to go ahead and move, let's see, this over. If it lets me, 1 second. Okay, there we go, I got it up. So AOM, and MOC are supplementary. We said that. So we need to say angles that form a linear pair are supplementary. Now we use the definition of supplementary angles, which means these two add to 180. And then instead of AOM and MOC, we're going to use substitution property and plug in what they equal, which is going to be 2x plus 30 and x. Okay, then we are going to use commutative property of addition. We can just say property of addition, and we're going to add the 2x and x. They use distributive property. You didn't have to do that. My face is in the way, I just noticed. Sorry. Okay, use distributive property, and then they're going to subtract property, and then division property. And we get x equals 50. So, again, each step is taken. Each step we have a justification. Again, it's the reason why we're doing it. Okay? We're only going to do one more problem, so bear with us. Here we go. Okay, this is our last problem, and it's a doozy. We're going to do what's called a proof. Okay? So, let's look at this picture. First of all, it tells me angle 1 and angle 3 are congruent. Okay? And we want to prove that AEC, okay, oops, there, I forgot about that. AEC is congruent to DEB. Okay? So we got to think of a logical process of how I'm going to show this. Okay? Well, let's think. How am I going to show that AEC, this orange piece here, is going to be congruent, and we'll call this the orange piece, right? How am I going to show that that's going to be congruent to this piece, the blue piece, which they have right here? Well, the first thing I notice is they both use angle 2, so they overlap angle 2, and they both have angle 1 and 3 that are congruent to each other. So if I kind of just threw numbers in there and tried to figure out that way, I don't know the angle measures, but let's just say 3 was 50 degrees. Well, then number 1 would also be 50 degrees because they're congruent. And then angle 2, doesn't matter what it is, but if it was 30, the blue would be 80 and the orange would be 80, so they would have to be congruent. So let's go ahead and see if we can break this down into a proof. Again, numbers we use, I use them just to give an idea of what's going on, but can we actually use them? Not really. Okay, so let's go ahead and try this out. Statement 1 is everybody's favorite. It's the given. Angle 1 is equal to angle 3. Why? Whoops, that's supposed to be 1. Given. Number 2. Okay, I want to show how AEC is made. It's made from angle 1 and angle 2. So I'm actually going to show, because I want to show that these two angles are actually the same. Okay, so I'm going to show that the measure of angle 1 plus the measure of angle 2 equals, that's an M, sorry, equals AEC. But also angle 2 and angle 3, so you can double up here. Angle 2 plus angle 3 equals the measure of DEB. So how do I know that's true? Well, that's called the angle addition postulate, right? Angle addition postulate. Okay, that's what states that. That two little angles add up to make a big angle. Okay, well, do you see how 2 and 2 are already congruent to each other? Yeah, they're the same. And I just got to show that 1 and 3 are the same, right? And then we can show that these are equivalent statements. Okay, so I'm going to substitute here. Instead of angle 1, I'm going to substitute this for angle 3. So here we go. The measure of angle 3 plus the measure of angle 2 is equal to the measure of angle AEC. How do I know that? Well, I use substitution, right? Angle 1 and 3 are the same, so instead of angle 1, I can substitute in angle 3. So this is substitution property. I just usually do sub property, and then for subtraction, I write out subtraction. Prop. Okay? So I substituted in angle 3 right here for angle 1. Right? Now, do you see how these are the two equivalent statements? Okay. Well, if M3 plus 2 is the same as 2 plus 3, then we can go ahead and say the measure of DEB is equal to the measure of AEC. And the reason? Again, substitution property. Okay, so that's the way that I logic through it. Now, I went kind of fast through this logic way, but there's more than one way to do this. Let's just take you through what the book showed. Now, you want to write the way I did it because it's going to be faster, but the book does it in another way. So let's go ahead and see what that looks like. Okay, so they're going to go ahead and run through this too. So one second, let me get it. Okay, so here they are. They give us the given. That's what we did. Okay. Now, they said 2 is equal to 2. Now, I probably should have said that, but we knew that 2 is equal to 2. 1 is equal to 3, and they added 2 to both sides. So they're taking a different approach to this than I did. So they did addition property of equality, which is fine. Okay. And then they did angle addition postulate for both angles, which we started with first, and then we then we did the equal sign by using substitution. So either way works for us. That's fine. Then they go ahead and they substitute it in. Okay? So, very similar to how I did it, but slightly different. Are both correct? Yeah, both are fine. Okay, so a lot of times we have different ways of doing it. Again, I knew how they did it before, so I made sure I did it a different way. But both work out. Okay? So we're going to get some practice with this, and we'll take baby steps. We're not going to jump into a full-on 2-column proof right away. Okay? All right, guys. Hasta luego. Luego, hasta. Dude, you see this watch right here? Look at like the blue shirt right here. Can you see? Look at I'm wearing red pants. I'm like Superman. Up and away. Not just kidding. Oh.